Okay, we have already learned in a previous video how to solve multi-step inequalities, and basically it's the same way as equations, except when you multiply or divide by a negative, you change the direction of the sign. Today we're going to do a couple that are a little interesting. I'm a little excited about this. So I'm going to go ahead and zoom in on my example A, and I have 2x plus 4 is less than 2x plus 6. I draw my line, and whenever I have x on both sides of the equal sign or the inequality sign, I get rid of the variable term first. I'm going to subtract 2x from both sides, and I find that these cancel out, and I get 4 is less than 6. This is a weird example because we canceled out our x's, and now we have 4 is less than 6. Let's think about this statement. When is 4 less than 6? Always. This will always work for every value of x because our x is canceled out. So this, when we graph it on the number line, we would say, I'd put in like 0 and then put in some other numbers here, and all numbers will work. So you're going to shade in or draw your line with your arrows for the entire number line. And this, normally we would say infinitely many solutions. You can say that for this as well. However, all inequalities have infinitely many solutions. So another way that mathematicians do this is math has like its own fun little language because mathematicians are lazy, so they like to write things differently. So if you want to be like super cool, you can say that x, or the variable, whatever it is an element of. It's like this funny looking E sign, kind of looks like a sideways pitchfork. X is an element of the real numbers. No matter what real number you have, X is all of them. And so it will work. You could also just use this funky little R symbol. You could be like, what's the answer? Every single real number that there is. And we're actually going to talk about real numbers in our next unit. So that's a nice little preview. Okay, let's look at B. This one has a few more steps to it. So I'm going to draw my line, and then I'm going to distribute. And I have 5 minus 10v. Remember when you're distributing that you're multiplying because that operation is multiplication. Okay, let's get rid of our extra variable term. I'm going to pick the smaller one, which is actually both of them. And I get 5 is greater than or equal to 12. So let's look at this statement. When is 5 greater than or equal to 12? Never. So this one would be your no solution. Just like equations, inequalities have times when any number will work or when no numbers will work. And you just need to read your equation at the end and say, when is that possible? Is 5 greater than or equal to 12? It's not. So this is no solution.